Hello. In this video, we're going to graph the function by finding the following information. We need to find the end behavior, the zeros, the multiplicity at the zeros, and the behavior at the zeros, and the y-intercept. To find the end behavior, we're going to look at the function f of x equals x to the fourth minus 2x cubed minus 8x squared. Notice that that's in general form. The leading power function is going to come from the leading term, which is just y equals x to the fourth power. And since x to the fourth power, that 4, it is degree 4, so it is an even degreed. So it's going to go up to the left and up to the right, or down to the left and down to the right, either one of the two. The first one is if the coefficient is positive. The second one is if the coefficient is negative. It has a leading coefficient of 1, so therefore it's positive, so we're going to have the function going up to the left and up to the right. To find the zeros, we set the function equal to 0 and solve. So x to the fourth minus 2x cubed minus 8x squared equals 0. Notice that there's a common factor of x squared here. So if we factor out the x squared, we're left with x squared minus 2x minus 4 is equal to 0. Fantastic. Now notice that we need to factor x squared minus 2x minus 4. So we have x squared times, and then what's left over here is just two sets of parentheses. There's an x and an x. This negative means that one's positive and one's negative. Ask yourself what multiplies to 4 and it has a difference of 2. Did I say 4? That should have been an 8. Why didn't y'all stop me? That's just ridiculous. Come on now. Anyway, as I was saying, whatever multiplies to 8 and has a difference of 2. Well, as far as I know, that would be 4 and 2. So the 2 in the middle is negative, which means we need to have the 4 to be negative and the 2 to be positive. Fantastic. And at this point, we just look at this and write down the zeros if you want. So x squared means we have a 0 of 0. X plus 2 means we have a 0 of negative 2. And x plus 4 means we have a 0 of positive 4. Or if you don't like that, set each factor equal to 0 and solve. The first one, you get x equal to 0. The second one, you subtract 2, so you get x equals negative 2. And then add 4, so you get x equals 4. Awesome. As for the multiplicity, look at the exponents here. X squared, well, that exponent is 2, so the multiplicity for 0 is 2. For the x plus 2, it has a multiplicity understood of 1, so the negative 2 has a multiplicity of 1. And for the 4, it has a multiplicity of 1 as well. So for the 0, the multiplicity of 2 means that it bounces off the x-axis. And for the multiplicities of 1, because they're odd, they cross. So it crosses at both negative 2 and 4. Outstanding. And to find the y-intercept, just ask yourself, what is f of 0? Well, just plug in 0 for everything and you're going to get 0. So 0, 0 is the y-intercept. Awesome. Anyway, now let's just kind of plot everything. Starting with, say, the zeros. We have a 0 of negative 2, 0, and 4. Awesome. Now let's look at the end behavior. Notice that we're going up to the left and up to the right. So beyond the last 0 to the left, we have to be going up. And beyond the last 0 to the right, we're going up. Now technically I say up to the left, but if you're looking at this, technically going from left to right, it's going down. Nothing wrong with that though. Anyway, at the negative 2, because that's the first 0 we see there, it crosses in a linear fashion because it's multiplicity of 1. So it crosses to the other side. At the 0, it bounces. So we're going back up towards the 0 and it'll bounce. And then at the 4, it crosses. So it'll go back towards the 4 and cross there. Awesome. And then just connect everything with a curve, or make it as smooth as possible. Again, it's not going to look perfect, especially if you type it into your calculator. It'll look very different from this, but the overall shape will be there. That's really what I'm looking for. To get the perfect shape, we would actually have to go through the calculus series, and to get there, you'd have to go through 1414, and, come and see me in 1414. We'll have fun in there. Anyway, I'll go ahead and leave it here, and I will see you in the next video. Have fun.